Welcome, everybody. My name is Jeff Payne. I'm the CEO and founder of Coveros. I'm going to be the host for this webinar. I've been building and testing software for 30 plus years. I do a lot of writing and speaking on all things Agile, DevOps, test automation, and integrating application security into the development process. I'm also the technical editor for Agile Connection. For those that aren't familiar with Coveros, so our business is helping people accelerate and modernize their software development process. We do that through coaching, consulting, and learning capabilities that improve agility, help you continuously deliver your applications, automate your testing and delivery process, and integrating security into that process. I always say we're a company with two brands. Coveros is our consulting, coaching, and training brand. And we also own and run software conferences. If you're familiar with the Star East, Star West conferences, the Agile DevOps, Agile plus DevOps East and Agile plus DevOps West conferences, we run those under our TechWall brand, as well as we also have some online communities that we provide free of charge to the software community. Agile Connection that I mentioned is our Agile DevOps community. Sticky Minds is our software testing community. And a new community we started recently is the TechWall Hub. It's a Slack-based community where software professionals can get questions answered, ask about tools and approaches for various types of things in a wide variety of software topics. As mentioned, all of those are free, so feel free to join up if you're interested in those particular areas of software. I am very happy to have with me longtime colleague and friend, Rich Mills. Rich, welcome to the webinar series, and why don't you introduce yourself?
Sure. Thanks a lot, Jeff. Thanks for having me. So as Jeff mentioned, he and I have been working together for many, many years. I started my career actually as a software developer and have had a very strong focus in software engineering and the use of automation and tools to deliver our software. So, I started very early in my career in doing things that were like automated build, became continuous integration. Eventually it was automated deployment. We called that, continuous deployment. And then they invented terms like DevOps to continue naming the things that I like to do. So I really appreciate that in the industry. It's always been quite fun. But certainly over the last few years, the advent of using Docker containers and containers in general as a replacement or an augmentation to the way we use virtualization has been very exciting for me. And I think it's one of the reasons that kind of led us to the topic we're going to have today. So thank you very much for having me, Jeff.
Thanks, Rich. So as Alexa mentioned, we are going to do a poll. So we're going to do that now. I'm going to stop sharing here in a second and we can talk about the results. But the question for the audience really is, how are you using containers today in your job? Go ahead and vote. Tell us how you use containers today, if at all. You'll see there are some categories for, well, maybe we haven't gotten there yet. So it is multiple choice, so you can select multiple categories.
Right. One of the selections is not, I store my coffee in a container. While that may be
those
true,
containers.
it's not exactly what we're looking for.
All right, exactly. So here we are. So number one is, what is a container? Not surprised. I mean, that's kind of the goal of this webinar, is to educate people on containers. It looks like, Rich, the second one is DevOps tooling to build my software. Any thoughts or comments on kind of how this poll shook out?
Yeah, no, it's actually, I'm glad we got a mix of people who are really just looking to find out what containers are and how you use them. And then we're kind of prefacing into what we're going to talk about a little bit, which is there's a number of ways that Docker containers come into the software development process. And it does look, the second option there, which is DevOps tooling to build my software, is definitely one of the topics I'll talk a little bit about. So I think this is a good mix. So good place to start.
Awesome. Thanks, Alexa. All right, we're going to jump right into it. So Rich, let's start at the beginning. So explain a little bit what a container is for people that aren't familiar with that. What is it? What it's all about, and how does it differ from how we've done the things that it does in the past?
Yeah, absolutely. So, and I think what I'll do here is let me share a picture because I think it's the easiest way to look at it. So what we're seeing here is, what are containers, right? And a little bit of a comparison. The easiest way, like to date, things like virtual machines have been pretty mainstream. There's a lot fewer people out there that are running like bare hardware racks of servers, and a lot more people, if you will, that are using the cloud and virtual machines. So a lot of us are familiar with the idea that in a virtual machine, which is kind of on the left hand of the screen, you have some kind of hardware and server underneath, but on top of that, you're running some kind of operating system, whether that be Windows or Linux. And on top of that, you install a bunch of software and middleware type stuff. And eventually you layer your application on top of that. And typically somebody will manage that VM for you, some operations group kind of thing. And then developers, deliver an app in the form of, could be a jar file if you're building Java, or a Node.js, zip file, or even on Windows, it's DLLs. And you just kind of layer that on top, and you kind of hope that stuff all works. Well, in the container world, what we see is we try to address the fact that that guest OS that's kind of in that middle layer gets repeated a lot. And it is a huge body of software that runs on these machines. And quite frankly, it takes up space, it takes up CPU resources. So when we move to something like Docker, and Docker is just one of the standards out there for how to build these containers, what we see is that gets squished down quite a bit. So you're running one copy of the host OS across the bottom, and then you simply just run your application on top of that with a thin layer of binaries and other libraries that you might need. So what we get is a lot more efficient kind of cost of scale, if you will, and that it's an easier way to make use of these resources that you're maybe paying for in the cloud, or maybe you are still running your own racks of servers. A lot more efficient. And then on the right-hand side, what we see is that there are many layers. I'm going to talk a little bit more about this layer later, but the real thing that you're building is that thing on top. So if it's a Java application, you have some Java jar file, right? And it's just a packaged up zip file of your actually application code. But then there's all this other stuff that may be specific to what you need to run your application. It could be Java libraries. It could be a Tomcat or a Spring Boot server of some kind, and that you need a specific version. Maybe you need version 7, somebody else needs something else. You got more libraries and libraries and libraries, and eventually maybe Java is loaded on this thing. And this is great because this all gets packaged as a single small tight image that runs these and only these things. So it becomes very easy to, there's a little Docker command in the corner that I'll revisit here in a few minutes, which is it's super easy to be able to run this entire stack just on any old machine. And that could be, your, virtual machines, your host, your servers, or it could be your workstation, right? So what we're starting to see and what people were leading towards is that this really gets you into containers in a couple different ways. And what I'll say is, there's using containers, meaning somebody else has built these applications for me and I'm just using them, versus actually producing containers, which is getting more towards what we're talking about here. Now, one of the things that I've seen is it's certainly much easier to get started in this whole using a container first, if you want to kind of dip your toe in the water, if you will.
That's great stuff, Rich. One question for you, and I guess the way I would ask it is there any reason to use a virtual machine any longer? I mean, are there use cases for using VMs any longer, or should you be moving to a containerized, approach in general? Why would you still use a VM?
Yeah, there are certain things where you might have very specific heavy duty resource utilization where you're looking to potentially isolate what you're doing and you don't want to have a lot of crossover of, Docker containers.
Security? Is security a reason?
Yeah, you could have performance reason. You could have security reasons, but I will say, there was initially fear in the world of, I don't know if these containers all running on my machine are going to be isolated from each other. And the isolation levels of the Docker and not just Docker, but the container implementations nowadays are very tight, and you very rarely see escaping from a container to potentially, jeopardize the operating system in any way. So is there a real good reason? Honestly, not one I could think of. A lot of people are going with these container first strategies right now, which is we're trying to use Docker for anything unless we can come up with a reason not to. And sometimes it's legacy reasons. Like you can't just magically take your apps and throw them into virtual machines. Like there is a transition you have to go through for that. So
that makes sense. And it looks to me like from your diagram that basically what what Docker or containerization is doing is it's stripping out a bunch of layers, really. I mean, it's room, and that I'm guessing means it usually runs faster for on a same size server, and maybe, and as you mentioned, more efficient because there's less running at any one time.
Yes, absolutely. Yeah. There's a couple things about that. You mentioned faster. So one of the big things with containers is startup time, right? If I want to start up, let's say I'm scaling and I need to add another web server to something, right? If I need to start up an entire VM just to boot my web server, it might take a minute, 2 minutes, 5 minutes for this VM to scale up. And then I finally get to a point where I can start my web server and that thing fires up in 10 seconds. Right. Well, with containers, you don't have that operating system startup time, right? The container, you just initiate the container and it spins up and you have a fully running web server in 10 seconds, right? So it becomes much, even if all you're doing is running your middleware and that kind of stuff, using containers for that, so much faster and so much more efficient, and better use of your resources and packing your resources into the hardware that you do have.
Oh, it's interesting. So you mentioned using versus building containers. So let's talk first about using a little bit. So how do you use containers in the development lifecycle?
Yeah, so I will say for anybody who hasn't started using containers or doing stuff with containers, using them first is a great way to get kind of introduced to what it means to run Docker containers and stuff. And the best way that I can think of to do that is to use Docker containers or containerization in general in, let's say, your DevOps build chain. So for example, let's say you're running a Jenkins server, and in the classic world, your ops team, your DevOps team somewhere, your development engineering teams will be running this Jenkins build server, and it's got kind of a master that dictates things, and then it's got a bunch of agents that do work, and those typically are a bunch of VMs. Well, by going to something like Docker, suddenly now you're able to just bundle these tools together. So if you're using, I don't know, Maven to build your applications or build some of your applications, but let's say maybe you also have some Windows apps that are being built with something other than that. Well, in the old world, you would need like a Windows VM and you would need a Linux VM and you'd have to scale these things out. Well, with Docker, again, you get much more efficiency and you get a lot of variety, which is I can use standard Maven containers, standard Java containers, standard, Node.js containers to launch all my little build services as part of my pipeline. And I don't need these huge build servers to be able to do that. It also makes it much easier to scale, which is if I start building more and more services, more and more applications, I can scale these things out very easily using Docker. It means you can also start leveraging stuff like you go from your classic kind of Jenkins, I run my own server, to let's say I want to do this with GitHub. I can use GitHub Actions, Circle CI, or a lot of these kind of online hosted frameworks where I just tell them, here's a Docker container to execute to be able to build the code that I want, right? So it's a very rapid kind of entry into the how do I get my build pipelines to really scale and grow up that much. So, and that's one of the things I've definitely seen a lot of. What's also nice, by the way, is by declaring what those containers are and saying I'm running Maven, 3.1.2 or, Java JDK 11.2, right? I can use those on my build server by pulling them off the internet and just boom, off I go and run them. Well, the developers can also run these exact same versions of the tools in their local environment. So it becomes much, much easier to kind of specify, if you will, the development tools that need to be. Long gone are the days where I have to spend 4 days, installing various development tools and other junk on my laptop just to be able to build a piece of software. I can just run some scripts with a few Docker commands in it and get all that stuff to build from the command line with really no problem at all.
So it sounds like you can use Docker to very easily define and configure dev environments, test environments, staging, pre-production environments, any of your environments. Is that true? Is that a use case for it?
Yes, that is absolutely true, which is once I can kind of capture and list out what those are, it becomes much easier to kind of define what goes into those environments. And even kind of roll through modern versions of it. Like, let's say I'm, changing from Java 10 to Java 11 or Java 11 and 12 or whatever. I can describe that, and that's what's running in production. And I can roll those through my development environments very easily. If I'm a tester, it becomes very easy for me to basically run a script and launch all of those little containers just on my workstation, right? It becomes easy for me as a, let's say, a DevOps build server guy to write a simple job, a self-servicing kind of job where somebody just pushes a button and boom, it fires up a bunch of Docker containers running a complete replica of a production-like environment, right? Where the resources are much more reduced. So I don't have these like, oh my God, I need 400 bajillion gigabytes of memory and all the CPU power, because I've been able to strip down these things and make them much smaller.
That's cool. So I'm guessing what that means is, instead of having, in a traditional world, you had a pipeline of static environments for the various things that you had, your dev environments, your test environments, they needed to be stood up and torn down. A lot of times that was done initially by hand, and then we started automating that a bit. And we started pushing code through and all that. But now we can spin those up and tear them down very quickly. We can make them all look more the same, right? Is that something we're trying to do? And are there benefits to getting our environments more standardized using something like Docker or containers?
Yeah, absolutely. And that's one of the biggest things that I've noticed is by kind of capturing that and being able to specify that out, the standardization of that becomes so much easier. I know exactly what these things are. I know what versions they are. Within that, I talked a little bit about the layers where you are, what's the best way to think? The layers where it used to be that all you would do is you would hand off your jar file to some operations group, and then they would run a bunch of deployment scripts. And even if you're using traditional stuff like Ansible or Chef or Puppet or whatever to do it, the point is they maintained all of those scripts, and the developers really, it was not very easy for a developer to use those kinds of scripts to be able to stand up their own environment. Well, now one of the things is I've got my layer of application code, but when I produce things, I don't produce a jar file anymore. I produce a fully bootable, runnable container image. So it has in there my jar file. It has my Spring Boot or Tomcat server. It has the right version of Java, and it's all built together. And my team can do that. And it's very easy to launch that and specify what that is. And even if there's another team that's using a completely different version of Java or different version of Maven to build it or whatever they're doing, they have their own stack bundled together so that I can now run these two things right next to each other. Where in a previous world, if I was using VMs or even just trying to run on my laptop, it's very unlikely I had multiple versions of Java or multiple versions of Tomcat running at the same time. It was very difficult for me to do that and very difficult to capture into an environment. So it really leads us sometimes in that, once you're comfortable using these tools and being able to deploy them, moving towards actually producing containers out of your application becomes that next natural step, so that I can capture my environments and I can capture my exact versions of software I'm rolling out and producing that for other people.
So speaking of production and producing containers, so let's talk about that aspect of it. So how do you move to containerize your applications themselves? And how do you make that your kind of operational platform? What are the activities involved in that? How do you leverage containers for that?
Yep. And I think the first thing is basically, the big step is as you start building out your services, whatever they may be. And in many cases, the world, everybody's talking about it, but the world is moving towards kind of microservices where you're getting these smaller and smaller application components that are doing. Well, Docker, because it's tight and very compartmentalized, and you can specify exactly the stuff you want in it, it becomes a natural evolution of, as you go into microservices, you can just start building containers instead of jar files or something like that, right? So that's kind of,
you would containerize each of your services potentially.
Yes.
And then you could push them through separately and change them and move them through the pipeline individually, right? In that environment.
Yeah, absolutely. And so typically what you'll find with these services is each of these services has their own pipeline, right? It has their own way that they go through a build and a unit test and a static analysis kind of thing. And certainly you want some consistency across your organization. But that then outputs now a Docker container, which is a fully runnable nugget, like operating system image almost, right? So you can just fire this thing up. So those start to become produced. And that's really the first stage is instead of producing like a jar file that somebody else has to install, you start building this nuggetized kind of Docker image, right? And then anybody can run that, from a tester to a developer to your production engineers, right? So that kind of goes, and again, kind of to influence, and maybe it's easier to kind of show the picture again. But really what it comes down to. So looking at my picture again, kind of on the right side, instead of your old view is you were really just producing this kind of top right Java jar thing and you were handing that off to somebody else to install. Now as a developer, you have complete control to build this thing, it's called a Docker file, but it's basically a spec that says, I need my jar file, but then I need this set of Java libraries that go with it. And I need this version of Tomcat and more libraries and, other things that get installed in it to make Tomcat work properly. And this version of Java, whatever it may be, right? And I bundle this all together and that becomes my container. So that really is the first step, is to be able to produce that. Because after that, then it's simply, you literally on the bottom here, it says Docker run my service, and you can pass it some environment variables and said, hey, by the way, here's the access URL to my database server. You are in 10 seconds or less, basically, you're firing up this thing and you're connecting it to a database and off you go. I don't have to worry about, installing Tomcat and installing all the libraries in Java and stuff on some serverware. It's just Docker and it just fires up. So that's really the first thing. And it enables things as you go to these containers, like heterogeneous build and heterogeneous application profiles, right? Which is, if this is running Java and I have more guys running Node.js, and maybe even I have a mixture of some old legacy Windows services, or, running a Python stack, or really any language you can think of, you build your own little baby stack, and it's totally in the development team's control to be able to specify what that is. So you get this kind of, heterogeneous, but standardization of the way that you build software. Which is really an enabling process. But it was, by the way, one of the weird transitions I went into a number of years ago when I went from, oh, well, I have a jar file and then I need to run a script somewhere to install it on a server. And the answer is no, you actually just produce that server image when you output from your build files. So very enabling, I think. Let's see. I can turn the picture off. So I think that's an important one. It becomes very easy to deploy these things. And again, you get that same software, that Docker run command I just showed you. You could be a developer or you could be a production engineer and you get the same thing. And what this really does is it leads the ability of, oh, if this is what I'm deploying very easily in production, hey, I got an idea. Can I deploy more of those? And the answer is yes. So we kind of mentioned that earlier. It becomes a lot easier to deploy more environments, more test environments. I don't need a dozen servers to be able to do this. I just need to be able to list out a set of containers, right? So one of the biggest enabling things that I really like about Docker is it's so easy to create on-demand environments, right? Which is I can write a job or even a script or anything where I just push a button or run a simple command and it will fire up. If you've got the world's simplest 3-tier application architecture, you got a web server and you got an application server and you got a database, I can fire all of those up and they will fire up in 10 to 30 seconds kind of thing by the time they come up and do. And if I can do that easily, I can tie that into my build pipelines, right? So now in my build pipeline, it's much easier for me to fire up a little environment with one or more containers in it, run a whole mess of tests against it, validate that my changes are good before I am able to move that on kind of towards production. So I think it really does accelerate your ability, if you will, to kind of build and deliver software quickly with small changes in an efficient way that can be, pushed all the way to production without a whole lot of grief compared to, some of the other big heavyweight processes that might have been in place before.
That's great stuff. So let's talk more about how containers can accelerate and improve the software development process and the test and delivery process as well. What are some of the things that, can you follow on your comments there about specifically some of the things that, Docker and containers can be used for in that regard?
I'm sure. I think one of the biggest trends out there in the industry right now is everybody's talking about shift left, right? It's like we want to try to bring a lot of those activities that were historically late lifecycle. Security is kind of your classic one, even performance in some cases are your classic kind of late lifecycle assessment activities where everybody agrees they're important. I need to run security scans. I need to talk to my security group. I need to review my applications and make sure I'm not doing anything wrong. When do I do that? And historically, it's been done by a security team at some point. But the problem is often it's too late, which is, you don't want to be finding, critical security problems late in your life cycle when you don't have time to fix it. You're like, oh, well, we're shipping tomorrow and we scanned it yesterday. We don't have time to fix anything, right? So using containers and containerization gives you nice compartmentalized nuggets, if you will, that are these images that you're producing, which can be scanned early in the life cycle. And so, for example, where we used to have to scan the operating system and make sure it's configured properly, make sure that you have the right configuration settings, no ports are open that aren't supposed to be, et cetera. Well, with things like Docker, I actually build that operating system image with all of its configuration much earlier in the life cycle. So I'm able to actually run a full scan to look for known vulnerabilities, problems with supply chain and libraries that I might have vulnerabilities in it. I'm able to do that at compiled time, right? Not once this thing is deployed and way down the road in production, right? I'm able to deploy these things or scan them almost instantly, which is a real acceleration of that whole security thing, right? So that's one of the biggest things that I like, is bringing that security assessment earlier in the life cycle.
Testing as well, functional testing too, right? I
Absolutely.
mean, historically testing's been at the end of the, traditional process, and that's
Right.
caused the same kinds of problems. When you find defects late in the life cycle, critical defects, you might not have time to find, fix them before a release goes out.
Yeah, absolutely. I talked a little bit about automatically being able to stand up and tear down test environments. Well, that is very enabling in the testing aspect, because now during my CI kind of build process, one of the things I can do while still on a feature branch, developing little features, I can build a container, I can stand it up, because it's very easy to launch these kind of, little test environments, and I can run real tests about it long before I've ever merged it to a development branch or thrown it into an integration environment. I can do those tests very, very early on. And this actually encourages behaviors like, oh, well, you know what? Let me kind of build and bundle my functional execution tests along with my source code, so that as I'm delivering updates to my source code, I deliver updates to my tests as well. And they travel along together through your kind of delivery pipeline. And anytime I fire up a container, I fire up the test right next to it and I can execute it. It's also, by the way, very enabling. And I have some other talks that I do periodically where I talk about how to use containers in testing. Is not only can I, if I'm building these tests that are right next to the code I'm imaging, if I package that up in the right way, hypothetically in a Docker container, hint suggestion, it enables other teams, people who don't know necessarily all the details about how to test my service. They can stand their own service up that perhaps depends on my service, or I depend on them, or they depend on me. I can actually very easily run a simple Docker command that runs their tests against their service, which might pass through and integrate with me, right? So it becomes very enabling to be able to build these test containers, and it really changes the way you think about testing.
Yeah, and I'm guessing from your comments about, obviously how you stand up and define your containers and what's in your containers, one of the reasons we've done some of those late life cycle assurance activities is because you needed production-like environments. Can you talk a little bit about how, kind of this idea of containers and standardizing environments, gets us away from having to do that, right, late in the life cycle?
Yeah, because you can do it early and you have this definition, it allows you to kind of do those testing early, and it gives your testers access to it. You can define your regression test, you can define your security test, you can integrate those into a test suite, you can tie it all back into your DevOps pipeline. So a lot of this thing happens automatically. I would say one of the things that becomes evident as you're going through this is that, wow, these are a lot of moving pieces. There's a lot of moving parts. Like, you're talking about running all these containers. Is it really that easy? And the answer is, well, it's not simple, but it is well defined, right? And it allows you to define production-like environments very early in the life cycle of things like high availability or scalability, which is, hey, I don't want just one of these things running. I want multiple running so that I can scale for performance. And I can also potentially have a higher availability so that if one of them fails, or for whatever reason, I still have other ones that are handling the load, right? Well, enter the picture of, systems that you may or may not have heard about out there, which are container orchestration systems, such as Kubernetes. And I actually do have a picture. So let me share that and we can talk through that a little bit. There we go. There's a picture. So here's a picture of what I will call your, kind of DevOps tooling and technology stack in the operating platform. And what we're really looking at, like you look at this thing, you're like, oh my goodness, this thing is an eye chart of tools. And the answer is, yeah, there's a lot of stuff on here, but there's really it's layers, right? And this is where Docker allows you to build these abstraction layers and get away from things. So because in the top, right hand side kind of uh, pretend these are your kind of test environments that you've deployed out there. And what you're trying to do is you're trying to accelerate your ability to get these things deployed and on top of things. And we do that by building all these kind of tools underneath it, where deep down underneath, maybe we have these kind of raw VMs that might be running. And on top of it, we have this system all Kubernetes that allows us to gather all of it, because any one of these tiny little boxes could be a container running, right? I could have, my DevOps tools on this left-hand side all running inside this cluster of kind of application resources. Well, all I want to be able to do is be able to replicate and get these environments up quickly. And typically what we define is you'll come up with some kind of specification, and there's tools out there. Helm is one of them, but there's a bunch of spec tools that allow you to basically define what each of these little tiny black boxes are, which could be an independent container, an independent service of yours. And by defining what these are and how they're deployed, you get to parameterize them and say, okay, I want 2 of these or 5 of these, or I want them to be automatically scaled so that if the load goes up such that I have more web traffic, let's say, give me, start with 2, but give me up to 20 web servers kind of thing. And a system like Kubernetes beforms your operating infrastructure that by nature just does this for you. So in the old world with virtual machines, I often had to define, I need load balancers, and I got to fire up these images, and I can install stuff on top of them when they come up, right? Well, with a system like Kubernetes, that's all built in, right? So it allows us to kind of orchestrate all these, thousands. I currently have, 150 different servers that are all bundled together as a cluster, running 3,000 or 4,000 different Docker containers, all independent processes doing stuff. And I'm able to do this very rapidly. Like I can take any one of these little square red and, black boxes and just replicate that to another environment by copying a spec file and firing the thing up. So it definitely allows me to kind of move through that stuff. And if I can do that, I can start running all of these historically late life cycle, assessments, opportunities, security scans, et cetera. I can run it much earlier in my life cycle. So that's that's one of the things that I think is very important.
That's great. And I'm guessing that means also then, if you're doing testing and you have, let's say, a large regression suite or a bunch of automated tests that you want to run very quickly or shift to the left and do them faster, that you can effectively use containers and orchestration to, run things in parallel, break it up, do all sorts of things to parallelize, speed things up. And it's all, if you set it up right, all managed and controlled for you. Is that is that a use case?
Yeah, no, absolutely. So we have things where, we run regression suites, right? And it used to be, well, I got to make sure I get it in my QA environment before I do it. Well, now I actually have situations where, because I can stand up dynamic test environments, I can actually make changes to one of my applications, one or more of my applications. I can run the regression suite against that, potentially even dictate, like do it on a branch before it moves to an integration environment. And I can find bugs in my regression suite. Like one of the worst things about testing sometimes is you deploy integrated integrated applications into an environment. You run your regression suite and you realize, oh, well, I have some fragile tests, or I have something that broke, or something that needs to be updated, or something that got missed. I need to go back and fix that, right? So, but your tests are now broken after you're into an integration environment. What you want to do is be able to run those tests as early as possible, right? Associate with them with the services or the applications they're associated with, update those tests, pre-run them first on your branches, so that by that time you get in your integration environment, you're really only focused on integration problems now, not on functional problems, right? So that's certainly one of the areas I can think of that you can accelerate that testing and getting that kind of stuff done earlier. Trying to think of what else.
Yeah, that's great stuff. I mean, it sounds to me like if you look at, obviously the cloud, you've got Agile, you've got DevOps, you've got microservices and service-oriented architectures. It almost seems like all that stuff is converging into, and they're supporting each other. I mean, Docker and this concept of lightweight, spin up, spin down really quickly, easily, orchestrate. That works really well in a services architecture. Can you talk a little bit about, the challenges with if you have a legacy application that's monolithic and wasn't really built to be service oriented or separate concerns? How much does that stymie, or what kind of challenges does that give you if you think you're gonna containerize your application, your pipeline? Is that a challenge?
It absolutely is. So if you have, your kind of classic monolithic architecture where even if it's multiple tier, where you've got a web server and you've separated that out, let's say, and then you have your core application services, which is this huge monolith. And then somewhere a database, let's say. One of the challenges and one of the reasons that is not necessarily the best thing in the world is, let's say, scalability, right? If I have this huge monolith and there's one important function in it that, let's say, is batch processing, right? And that thing fires up once a night and it, uses huge amounts of CPU and RAM and does all this work kind of thing. Well, with that huge monolithic application, one of the impacts there is that if the users are also using the front end of that system, then that impacts CPU load of that entire thing, right? So you could slow down user response times, all because some batch processing is going on in the back. So that's one of the natural things you want to split off. And in a microservices world, it's great because you just, you spin up more of those batch processors, meanwhile, the user interface stuff. So if you're stuck in a monolithic world that way, then going to Docker isn't going to solve your problem, right? Because if you still need 64 gigs of RAM and 16 CPUs to be able to execute your thing, sure, you can do it. You're just not going to get a huge benefit from it because it's not like I can get more of these things very easily. I still end up spinning up an entire new virtual machine node just to host the one more Docker container I need. So that's certainly one of the challenges with legacy. That's certainly the biggest one that comes to mind. I'm trying to think of maybe if there are some other ones, but that's the biggest one I think I've seen.
Yeah, no, that makes sense. That's great stuff, Rich. So I know you're speaking a couple times coming up. You want to put a plug into some talks you're giving coming up for the audience?
And potentially relevant. So 24-hour, the yearly all-day DevOps conference, which goes for 24 hours and is hosted by, I think it's
Sonatype.
Yep. It starts on this Thursday, so it's 48 hours away, kind of thing. And I'm doing kind of a fun talk that used to be a 5-minute kind of speed DevOps lightning talk, but I've expanded out to a 30-minute session, which is 5 signs you've DevOpsed your microservices wrong. And it's kind of a fun talk where I talk about the fact that, okay, you're trying to go to microservices. Sometimes you land somewhere not quite there. What are some of the problems with not having the right kind of automation in place, not having enough testing in place, which is always a massive problem. And quite frankly, how to structure teams. So that's coming up just this Thursday, which I think will be a lot of fun. It's always a good talk. So. And certainly anybody else that hasn't attended some of the all-day DevOps, there's usually some great talks that go on around the globe for 24 hours. So certainly encourage you guys to come join us over there.
Nice. That's great stuff, Rich. We are going to take questions here in a second, but before we do, just some quick reminders of some opportunities that are coming up for you all to learn more about these topics. So we have some upcoming live virtual classes at Coveros. Our Foundations of DevOps class is coming up in early November. We have our Agile and DevOps leadership class coming up in December. A brand new class, which I know Rich is involved in building, called Designing CI/CD around Microservices and Containers. We're targeting March for that to do. So those are all classes that are relevant to the topic here. And then don't forget, we do have our upcoming Agile plus DevOps East conference. It is going to be all virtual this year. And there are a bunch of different talks around microservices, serverless, CI/CD pipelines, integrating testing, all sorts of fun talks there. So don't miss that as well. Also want to mention, I mentioned the hub before. Definitely continue the conversation. We're going to take questions here in a sec. But if you have additional questions after this, or you want to talk more about this, I know I'm going to jump over to the hub after this and go into the DevOps channel. I think Rich is going to try to jump over as well. So if we don't get to questions in the next 15 minutes here or so, feel free to jump over there. If you just want to talk, offline, we're happy to do that. So with that, I'm going to stop sharing here and we're going to take questions. Alexa, you want to facilitate that?
Yes, our first question is from Harold. So if containers are used, then is the flow a dev container goes to a QA container, then to potentially a prod container?
Not quite. The whole idea is when you build a container, it's much like producing a versioned, some version number of your application. So if I build my app, 1.2.4, right? This becomes a development build that's a brand new version of my app. Well, it just happens to get packaged as a Docker image container, right? And then what I do is I take that version and that gets stored in a registry somewhere, much like if you were building jar files or something, you would store that in Nexus in a repository, and later you would pull that down and deploy it somewhere. Well, with Docker, same thing. You have a registry, which is a central, storage system in your enterprise that stores these Docker containers, and they have specific tagged versions associated with them. So I install version 1.2.3 into my dev environment, and I run basic development tests against it. Assuming that passes, I will take that exact same version, dev 1.2.3, and I will install it into QA, right? And so exact same binary version, it'll just be connected to potentially, be wired together with potentially a different data set, right? So it still points to a database, but it's the QA database instead of something else. And then eventually, assuming that passes all its regression and security tests, I'll move it on to staging and eventually on to production. So that version that I built once in development ultimately gets to production, assuming it gets promoted far enough with all of its, test passing and assessments and things like that.
Thank you, Rich.
Mm-hmm.
Our next question from Paul is a two-part question. How do these containers interact with data? And for testing, can you have different data sources by environment?
The answer is absolutely. So you still have a separation of, you have an application container running, and then it connects to a data source somewhere, right? Almost all of our applications always have some persistent store behind it, which could be anything from a file system to, your classic database. So if we take a classic SQL database, when I install it in dev, I connect to the quote dev database, which has some set of data in it. When I connect it, and I mentioned this before, when I install it into QA, that has its own database set, right? And then eventually prod, which has live production data. One of the other advantages I will say is if you start using containers, and for example, you're deploying your databases as containers, and this is similar to if you're deploying managed databases, a lot of times you can snapshot a set of data. So for example, one of the things we do is we run, let's say SQL servers, right? I run a MySQL server in my development environment that has a known data set in it. And then I might deploy code into it, test it, create data, mess up data, do whatever I want to do, corrupt the data set and go, I don't want this anymore. I basically throw it away and I just reinitialize that snapshot basically container that may have data in it already, and boom, up it comes and it's brand new. So from a development standpoint, this is super useful for me as a developer on my local workstation or a tester on my local workstation, where it's easy for me to grab data sets, fire them up and test against it. Where something like production, you're obviously not going to tear it down and rebuild it. You use true persistence mechanisms and backup and replication. So absolutely, yes, you connect the data. It's really just as a configuration parameter when you actually fire up the container of which database to connect to. It's a connection string, just like any other deployment. And then I can manage data. I will say in any CI/CD process, data is always the hardest part, right? Because your data defines, what your tests are going to do. So there's, regardless of whether you're using containers or anything else, data is always a little bit of a challenge.
Regarding, so that sparks a question that I would have in terms of how hard is it to get containers to talk to other containers? So what are the security issues or ramifications to doing that? Because obviously there's got to be some security concerns. You're going to have to open something up and they're going to have to communicate.
Yeah, absolutely.
And if you can do it, how do you secure it then? Make sure it's still safe.
Yeah, it's a very good question. And the answer is anytime, just like any other application you fire up, there's a certain set of parameters to start the application, right? And I might need a database user with, a username and a password. I need the remote connection string and the addresses. That's your kind of classic copy. There may be other remote services out there, which is I'm a web server. I need to talk to app servers, right? Well, a lot of, first of all, the orchestration frameworks, and this is everything from just raw Docker to Kubernetes, if you will, always provide what they call service discovery capabilities, which is you effectively associate an arbitrary name to something else that's going to run. So, I may call it web, like literally WEB, EB, and app and DB kind of thing. So they have kind of symbolic names running in my virtual network. And with Docker and with the containers and Kubernetes, you create these little isolated baby networks that only open the ports that you care about, right? So one of the nice security postures is because I'm only running my web server, I don't have an SSH server and a telnet server and all this other cruft running on my operating system. It's really tight and really slim. And I open one or two little ports. So it's actually very easy to secure Docker containers so that you can reach them the way you're supposed to. And you're not reaching all this other cruft that could be hanging around that really just, expands your attack platform, right? You don't want to provide more things to attack. So security in Docker can actually be much stronger than having these really broad, like blown up virtual machines, if you will.
Do you have other questions, Alexa?
There is one more question. Our organization is not yet using containers. In your opinion, where should we start? Which team should start?
Yeah, so a lot of times what you're going to find is that your operational and your DevOps team are going to be the ones who run them, right? They need to stand up and install the tools that can run Docker containers and do things. So what I typically suggest is, remember I said there's kind of two ways you can get started with containers. The first is, quote, using containers, and the second is producing containers. So I don't always suggest just jump right into trying to put, start building your apps as a container and push it to production, right? There's definitely a learning curve associated with learning how to manage Docker and configure Docker containers and stuff like that. And the easiest way to do that is for your developers, maybe your DevOps kind of tooling team, whoever manages your build servers, and to some extent your operations teams to use, just pre-packaged containers everywhere from like running a database application server to running, Nginx web servers or Apache web servers, but learn how to use the build tools associated with making containers first or using containers. And that really allows you to kind of tip your toe in the water slowly without overcommitting to it. And that's usually where I tell people is get the developers to start learning how to use Docker on their desktop, get the DevOps tooling people to start using it in the build pipelines to, execute builds and containers and scale out and make their pipelines work. And then potentially your operation people to deploy some of their apps that they use on a regular basis that they might just download off the internet or run open source or even get from vendors. That's where I would start.
That's great stuff, Rich. One question for you on the security and quality of the containers themselves. I know there's tools out there that help you, kind of protect those containers, make sure what you're doing in those containers is reliable. What kinds of tools and techniques are out there for, inside of containers, kind of making sure things are secure and reliable?
Yeah, and a lot of the mentality I think comes from the open source world, if you will, in that one, you have a supply chain thing, which is containers are actually built out of many, many layers. So you tend to pull different layers together. You start with a really tight operating system and whatnot. And these are at least scanned and studied very heavily on the internet. And there are published CVE vulnerability exposure databases out there that will tell you when these have exposures to them, right? And there are a lot of open source tools that are both integrated into these public online registries that automatically scan this whole supply chain constantly. So if Tony J. Smith uploads some cool little utility container that you're thinking about using, that has already been scanned heavily by the various tools out there. Is it a guarantee there's nothing malicious in there? Absolutely not. And you definitely want to look at the pedigree of who this Tony J. Smith is, and what's the risk impact of running this utility container or something like that in your enterprise. Now, one of the neat things is by running this container off the internet, it runs in they use the word container for a reason. It's isolated. It's a sandbox. It doesn't have access to a whole lot of stuff around it. There's nothing else running in it. It's not like you're running it in the same, I don't know, process space or operating space as your server, right? The server stands up a very tight sandbox around all these containers. So even if it is running there, it has a lot less of a chance of impacting the other processes that might be running on that server. So again, I've become a big fan of the security profile of Docker and how it actually enhances your security, not jeopardizes it.
That's great stuff. Any additional questions, Alexa?
Checking chat. Nope, no more questions.
All right. Well, I want to thank everybody for coming, and please definitely check out the hub if you're interested. As mentioned, we're going to head over there next. Thank you all for attending this webinar. We will be starting back up our webinar series in early 2022. So stay tuned for announcements on the next speaker for our webinar. Thanks everybody for coming. Thanks, Rich, for participating today. It was great.
Well, thanks for having me again, and hopefully we'll talk to some more of you online. But thank you everyone for your time.
Yeah, thanks everybody.